Hey there, I'm Pascal and welcome to another Home Automator tutorial. In this series, Coding Practices, Tips and Tricks, we are looking to take our skills to the next level by modularizing and improving our code and techniques. This is the intermediate version of my popular ESPHome Basic setup for all devices in episodic format. Today, we'll create our first generic board configuration using everything we've learned in both the previous two installments in this series and my other series where we are building an over-the-top room sensor. And in the next tutorial in this series, we will be compiling our first firmware. Cards to the series above here. If you've seen any of my previous tutorials, welcome back. If you're new here, welcome, and I hope that you'll like what I'm doing. I know that your time is valuable, so the tutorial has chapters which you can access on the video timeline or in the description. Before we start, I'd like to remind you all that scripts are on my GitHub page and the link is in the description. I've also enabled the discussion module on GitHub to be able to speak to you between videos. So let's start discussing ESPHome. If you have any questions, feel free to leave it in the comments below or on GitHub, and I will try my best to answer you. Or maybe somebody else in the community might have some more information. Also, if you think there is a better way to approach things, feel free to voice your opinion. We are all here to learn. If you like this tutorial, please like, subscribe, and hit the notification bell. And don't forget, you can also share. This will enable the YouTube algorithm to present this tutorial to more people. But I think it's time to start. Before we start, I will assume a few things. I will assume that all of you have at least Home Assistant and ESPHome installed. We'll also need the Studio Code add-on or Visual Studio Code desktop. I will leave links to my tutorials on GitHub. Before we start talking about code, let's talk a little bit more about commenting. I know I've touched on this before, but this is how I comment my files. And I am going to show that to you right now. This is the way I comment my files. The first section is about what the file is. So in this case, it's generic board properties. In my case, I put reference or references. In this case is ESPHome.io, and the tutorial series this is linked to. That's for you. You don't have to put that. Then I go on to the usage. Include the following code in the package section of the device file. And it's as easy as copying this section, putting it into the device file, and the device file is this file in the root. And we talk about device files in a later tutorial. Then notes. Sometimes I have notes. This doesn't work, or be careful. In this case, we have a problem with this, or this or that, or the next thing. Again, the few next lines are strictly for me. Author is Pascal Parent, myself. Company is Home Automator ZA, which is actually the YouTube channel, where you can find me on the web, which is youtube.com/Home Automator ZA. The GitHub repository where this file comes from, the version. For me, it's very important to know that I've changed versions, and I'll tell you why. A version may break past devices. It may happen, and you'll pick it up sometimes only when you recompile on a new version of ESPHome. The license, I give my code away, so pretty much the license is public domain. A couple of warnings. This code carries, it works on my setup. It's a disclaimer, and then use it at your own risk. These are things to cover me. Again, you don't need to do that. Before we start writing code, it is essential that we identify the attributes shared by boards and how to split them apart. This will allow us to prepare our modules accordingly. For example, we can think of the Wi-Fi and Bluetooth as found in most ESP32 development boards. Therefore, these could be modules. And these are part of our network modules. So what we are going to do inside of the code, we are going to go to common because obviously it is a common, and obviously it's common attributes, and we are going to create a new folder. And this new folder is going to be called networks, or rather network. Network, yes. In that folder, we are going to create two modules. And a module is often going to be a single file. So here we'll have Wi-Fi.yaml and a new file called Bluetooth. And for some odd reason, I keep forgetting the E. .yaml. And now we've got our network environment modularized. There is one more file that I would like to put into networks, and that is the web server, which I do believe belongs in here too. Now, why would I have the web server separated from Wi-Fi? Very simply, if we take this module, which is the Raspberry Pi Pico RP2040, try to run the web server on it. It's not going to work. In fact, there are some exceptions which are directly related to the RP2040. We'll get to those in a later tutorial. Now that we've got our network sorted, we can think about everything else that is common to every single MCU board combinations. I talk about an MCU board combination because there are MCUs such as the ESP32S3 which differ from board to board. There is the reference board, which is this fellow, and then there are other boards that use the ESP32S3, which I cannot show you right now, but they do exist, and they are very, very different. In fact, I've got one here that has both a GDI out as well as a camera in. So that board is very, very different. And in fact, it has different pins when we start talking about things like UART and I2C and I2S and so forth. So what are the common properties that are for every board? For one, Home Assistant API. How about the logger? Over-the-air updates or OTA, uptime, status, restart, start in safe mode, and there are others, and we will address them as and when we need them. At this stage, we can categorize the entities into three groups: board and MCU specific entities, network entities, and common entities. Now that we've done that, we can start coding with a modular approach in mind, and we have started this modular approach already. As a matter of interest, we will be using the ESP32C3, this one to be exact, as our basis for all of these tutorials, or most of these tutorials. And I want to thank Stephen for sending me two of them. I've been enjoying them quite thoroughly. In total, we end up with 6 modules for our files. The board MCU module, the Bluetooth module, the web server module, the Wi-Fi module, the settings module. You may ask why the Wi-Fi and Bluetooth modules are separate. There are several reasons for that, but the main reason is that it's very simple. This is an ESP8266, and it does not have Bluetooth. This is the equivalent ESP32 Mini, and this has Bluetooth. As of the writing of this tutorial, the RP2040 with the Wi-Fi module, its Bluetooth module was not enabled. Bluetooth has to be separate. And in fact, Bluetooth, I will discuss in length in a future tutorial. It is far broader than the basics I'm going to show you today. But I think it is time to get to the next section. Now that we have our basic modules, how do we categorize them? Now, we've started that already. Using folders is the best way. But how do we go deeper into our categorization? How do we do things so that we don't get lost? Let's go through some of the folders now. The first one would be boards. And you will see ESP32, ESP8266, and RP2040. They represent the majority of MCU board combinations that we can have. Now, I use the MCU as a basis for the folder. It is possible that in the future we may have a BK32 or an RTL87 or, I don't know, a new Pico RP2350. And I separate by MCUs, and each board related to MCUs and specific MCU like the ESP32S or S3 would be a file within that. And let me show you what I did with the ESP32. You will see that there is a C3 mini expressive. Now the C3 mini expressive, I've shown you already, this is this fellow. And then I've got the secret.yaml. And the secret.yaml, I think I showed you in the last tutorial, doesn't have much in it. Now let's move on to common. Now we've been in common already in this tutorial, but I want to address particularly the network side of things. Today we have Bluetooth, web server, and Wi-Fi. It doesn't mean that we have to stop there. Sooner or later, I expect that Thread and Zigbee will be available in ESPHome. That means that Matter will also be available. These will come into the network folder. When it comes to naming convention for the boards, I adhere to the following. Board model, in this case C3 Mini, and manufacturer. In this case, expressive. Isn't it supposed to be espressive? So let me rename this as well. Espressive. There you are. I do not need to put the MCU because the MCU is an ESP32. That solves that problem. I know where my ESP32s are. Now, obviously, I could go ESP32, create a new folder for the C3, and then say mini expressive or whatever else it may be. I think it's going too deep. My personal preference. By the way, the inclusion of the board manufacturer is not always necessary. In fact, in some cases, I don't do it at all. And in some cases, it is essential. And I'm going to take an example. The ESP32S3 is a very, very good example. Now, this is the ESP32S3 reference board. There we are. It has a RGB LED and 2 ports. However, the DF robot version of the ESP32S3 is very different. It does not have the RGB LED on it, but it has 2 other ports. One of them is a GDI port, which is for a screen, graphic display interface, I think it stands for. And the other one is a camera interface. So all of a sudden, you have more standard interfaces on a single board, but both of them are ESP32S3s. Now, you've probably seen what a ESP32S is, because I use them for most of my tutorial. But how about I show you another one? This one. So this is an ESP32S. That port that you see on the side here, that's the port for a screen. And it is a specialized board. And This specific one is for ePaper, and it is an ePaper driver board. It has all of the normal functions of a 32S plus the driver board for the ePaper. If you want another one that's very different, this is also an ESP32S. Here it is, and you must see these around. This is the ESP32CAN. Now, all of these boards have different UART ports or UART pins, different I2C, different I2S, and many other things that are different about them. So we need to create a single file to describe those boards every time. And that's what I call a module. Next, let's talk about entity property standards. Now, let me talk a bit about properties and my way and my standards. It may very well make your life easier as well. My entities follow an order, or at least I try to follow this order mostly. And I will leave this in my GitHub page for this tutorial. But in short, it's ID, name, icon, whatever else, lambda, filters, unit of measurements, update interval, device class, entity categories, internal, disabled by default, web server sorting weight, and automations. Now, there are some that you may not know about just yet, but trust me, you'll understand what they are at a later stage. Since I often look at the IDs, they're at the top, and pretty much the top and the bottom are, for me, the more important ones. So I order them in that manner. Finally, some code. When creating models, I strive to maintain a focus on single concerns, as I have discussed previously. This allows me to keep the code organized and manageable. For example, a module may be dedicated to a task such as Wi-Fi connectivity, or the DHT22 sensor readings, or managing faults. Whilst it is important to have well-defined boundaries for each module, it is also important to avoid fragmenting the code to the point where it resembles a chaotic monolithic system, which we're trying to avoid. It would make a full circle, and we don't want to go there. In some cases, it may be necessary to have modules that address multiple concerns. For instance, as I've said before, the settings and the boards module encompass various functionalities that are common across all microcontrollers and boards. In this section, we are going to dive into the settings module and discuss how the common entities will be integrated into it. We've already got the settings file. Now let's add some code to it. The first section I want to address is what I call the generic board configuration. Basically, things that are belonging to the board and that we will be putting into the setting file. ESPHome being the first of these. So we are going to put the ESPHome entity, and it only has two properties, name and friendly name, in this file. We can add properties, and we will add properties to it in a separate file, because we can reuse these entities in other files. The second one is the logger entity. And again, that's all that there is to it. The logger property just enables logging. Yes, we can go further and tell it how to log and what to log, but we can do that in the device file. After that, we have the API file. And that's what it looks like. Now, this is strictly for communicating with Home Assistant, and we can see that we've got a problem. Unresolved tag secret. Now, I wouldn't worry too much about that. It's not going to affect our compilation. This is because it cannot find the secret file in this folder. So how do we fix this? We copy the secret file that we have created here. We go to core and we paste it. And hopefully, and you can see what it looks like, and hopefully it will disappear. And what? Sometimes it works, sometimes it doesn't. Next, is the API key. Obviously, we will have to make sure that this key here exists in our secrets.yaml. Now, if you want a template for the secrets.yaml, I will drop in one on the GitHub page for this tutorial. Next is going to be the OTA settings. And here are the OTA. And again, very simple, platform ESPHome, password, and the password is in the secrets file. Next is the safe mode for the OTA to be able to function. And this is relatively recent, and this is my version of it. There's not much to this. I also included some network settings, namely the MDNS. I make sure that it is enabled so that we can find our devices on the network that we have created for that. I've got a separate network for all of my IoT devices. The last one in the network is I disable IPv6. That may be a problem in the future because as I read it and as I understand it, Meta will require IPv6. The next one is a binary sensor that exists on all of our boards, and that is the status. Now, it may sound silly to have the status, which basically says I'm connected to Home Assistant. But once you've got a screen, this becomes a whole different thing. So let me show you a little device. So this is a little device that has a screen, and I don't know if you can see that there are three icons at the top on the right hand side over there, and those three icons show us the Wi-Fi state, the connection to ESPHome or Home Assistant, in fact, the Bluetooth state. And by the way, this is what we are trying to create for our room sensor at the end of the day. And if you want to see it differently, this is the Fire Beetle, which I was talking about earlier on. So binary sensor status is useful in these scenarios. Next is the uptime sensor, which is here. And all it does is that it gives us the uptime every 30 seconds and in seconds, by the way. Something that we will be addressing in a future tutorial as well. The next one is the version number. Now, this is the ESPHome version number. And here it is. It's very simple. It returns the ESPHome version of the device. The following one is the restart switch, I think. Yes. And as it says, it's a switch and it restarts the device. That's it. And then there is the safe mode switch, which restarts the device and puts it into safe mode on restart. So these are the essential elements that we need for the settings file and for a board to work. To keep this tutorial as short as possible, we'll cover additional settings in future video. When we go into templates and explore advanced component properties, I will demonstrate some useful properties and create human-readable sensors from these sensors. And this concludes the setting file. I will leave this file on my GitHub repository for this tutorial. Next, I think it's time to get onto networks. Let's address our next module. And our next module is going to be about Wi-Fi and network. So let's do the Wi-Fi component. As you can see, I've got my forward or my notes about this and what it requires. So here it uses the following substitution from the project files, such as device internal name, device sampling time, and so forth. In the secrets file, we'll need the Wi-Fi SSID, Wi-Fi password, and a few other things. Okay, so I'm just going to go off and let's talk about the first section. And the first section is the Wi-Fi section. This is what will allow us to connect to an AP or access point. In my case, and I think I've explained this before, I always use a manual IP address. Now, obviously, this is something that is a preference, but by using IP addresses, I have a spreadsheet with all of my IP addresses, and I can always find out which device it is that I am dealing with, or I can find where the device is supposed to be. All you really need is the first four lines, which is Wi-Fi, networks, SSID, and password. After that, we've got the AP or access point, which allows us to connect to the device without having it connected to an access point and to a network. Again, we need an SSID, and again, we need a password. Right. After that, we have something called Captive Portal. I don't use Captive Portal, but I still put it in. And Captive Portal allows us to log onto the device and give it a network to connect onto without using a manual IP or networks. This will allow us to connect to the device and define those. If you're going to do a device for a friend or commercially, this is very handy because you can give the device to somebody and all they have to do is log on to it, say, and give their SSID for their Wi-Fi, their password, and even other information such as IP address and subnet and gateways and such. Let's move on. And the next one is our sensors section. And our sensors section has one single sensor, and that sensor is a Wi-Fi signal. And you will see that I appended DB. Now, that is because we're going to come back to this sensor and we're going to do a few things to it in the future to give us something that is more readable, more human-friendly. And the last one is a text sensor, and this is the Wi-Fi information text sensor. We will also modify this one in the future to make it more friendly for us. So that is our Wi-Fi module file for today. Now we're going to quickly do the basics for the Bluetooth module. And to be honest, it's the Bluetooth tracker module to be exact. So I'm going to rename this. We're going to rename this to Bluetooth tracker. I'm just going to copy paste it there, quickly go through a few things for you. There is a whole lot of notes that are worth reading. It's not compatible with the ESP8266 and the Raspberry Pi Pico. And lastly, because of the amount of RAM that is used by Bluetooth, if you are on or if you're using a board that has little SRAM and no PSRAM whatsoever, I would avoid Bluetooth if you're using either the web server or voice assistant. In fact, Bluetooth web server and voice assistant are pretty much exclusive to one another. There are exceptions to this. The S3, which has 8 megs or 4 megs of PSRAM, I can never remember, can do web server and Bluetooth. I know this because I've tested it. However, on an ESP32S, it just goes into a reboot loop. Okay, so the first thing, and maybe you haven't seen this before, ESP32_BLE. Enable on boot, true. That forces the Bluetooth module and the Bluetooth radio on. ESP32_BLE tracker, you've probably used it in the past and seen it, so I'm not going to explain that right now. And then there is a proxy, which is very useful in certain cases, and active is equal to true. I'm not going to go, as I said, I will treat Bluetooth in a separate video a little bit down the line, and I will go in depth. Yeah, I'll leave the Bluetooth tracker to that. The last module in our network-related modules and files is the web server. The web server is very straightforward. Again, you can see all of my, except that I should really take out this line. You can see all of my nodes, and I want to bring up some of those. It requires either Wi-Fi or Ethernet to be enabled. Without either of these, the web server will kick out an error and you will not be able to compile the firmware. It uses the following secrets from the secrets file: web server user and web server password. Again, same warning about the SRAM and PSRAM. We've gone over this. I'm not going to do it again. And this is what it looks like. There is nothing funny about this, except that you've maybe never used version and include internal. So what are those two? Version is the version of the web server that is going to be used. And I use version 3. And you will see that in the next tutorial, version 3 is quite different to version 2. Include internal. There are some sensors that are internal, and internal allows us to hide these sensors completely from Home Assistant. They will still be visible inside of the web server if you say include internal is equal to true. Last piece, local is true. Let's get to the next section. Okay, so you need to have a fantastic time until I see you again. I will remind you that we will be revisiting all of these modules, elements, and properties to make them more functional in upcoming tutorials. The code is on my GitHub page. Link is in the description. I hope that you found this tutorial helpful and enjoyable. If you did, please consider liking, subscribing, hitting that notification bell so that you never miss out on future videos. And thank you. This is Pascal signing off. See you in the next tutorial.